Alrighty. Well, hey everyone. Thanks for taking the time to listen. So my name's Mitch. Like Jonathan said, I work at Shopify. And today I'm going to tell you a story of how we're making commerce extensible with WebAssembly. So that's me with shorter hair. I've got quarantine hair now. Graduated University of Waterloo, went to University of Waterloo, class of 2009. I've lived in Waterloo my whole life. It's a little town about an hour west of Toronto up in Canada. Big tech city. It was the birthplace of BlackBerry for those old enough to remember. And I've spent most of my career sort of working in startups. And since 2018, I've been a development manager at Shopify. So what is Shopify? It is founded in 2004, IPO'd in 2015, so it's been around for quite some time. It started as a software platform to help entrepreneurs start a business and sell online, and since then it's evolved into a multi-channel software as a service commerce platform, powering over 1 million merchants globally today. So somebody says, anyways, if you've bought something online and it wasn't from Amazon, it was probably from a Shopify merchant, at least if you're in the United States or North America. And it's actually, I had here in my slide notes, like it was Canada's largest technology company by market cap, but actually as of, I think last week, it's now Canada's largest company, period, on the Toronto Stock Exchange by market cap. So it's grown like crazy. Headquarters in Ottawa. Pretty cool company. So then we have Shopify Plus. And so at Shopify, we support a broad spectrum of merchants, from independent business owners selling trinkets out of a garage all the way to global businesses doing $100 million revenue. And so Shopify Plus is Shopify, but it's for high complexity or high revenue merchants. So those merchants at the really top end of the spectrum, operating globally, doing lots and lots of sales. And so I work on Plus, and as an engineer working on Plus, I get to work on the problems experienced by some of these largest merchants. And as you might imagine, some of these problems range from like volume-based scalability challenges. So a lot of these flash sellers generating just crazy load on the platform, all at a specific point in time when, Kanye drops a new pair of sneakers or something like that, and all the way to product complexity challenges. But today I'm going to talk to you about the challenge of how we make commerce extensible. But before I get into that, I'm going to dive a little bit into the tech stack of Shopify. And so Ruby on Rails. So Shopify, the core of Shopify is a 15-year-old Rails monolith. It's got to be one of the biggest Rails code bases in the world, if not the biggest. Not too sure if anyone's bigger, but it's grown up. Shopify's grown up with Rails since the very early days of it, and it's proven to be the right choice for the company in many ways. This image here is from a Shopify blog post about modular monoliths. And so on the y-axis, we have modularity, and on the x-axis, we have deployment units. And so assuming that a system has enough modularity to avoid the ball of mudness at the bottom, we have what amounts to a modular monolith versus microservice architecture. And Shopify sits kind of somewhere here-ish. And over time, it's trending more upwards as various teams refactor, reorganize, and figure out how 1,000 developers can continue to be productive working on a single Rails repo. We do have other services to take care of other jobs, but the core of the platform is really that Rails app that sits in the middle. It's our center of gravity. And so with so much diversity across our merchants' businesses, and with so many teams working on Shopify on an architecture like this, it's very critical to be disciplined and thoughtful when it comes to building product. We want to keep the out-of-the-box experience really simple for merchants and prevent our code from drifting downwards into the ball of mud. And so how do we do that? We have this product principle internally, which is we build what most merchants need most of the time. And so what this ensures that the things we build apply broadly to our diverse set of merchants while keeping the product and code base simple. But an outcome of this principle is that as the number of merchants grow, the number of things that apply to most of them most of the time, which is to say the intersection of the useful feature set, it actually gets smaller by definition. So over time, that core offering must get smaller. And so, but on the other hand, we need to solve more and more requirements. So what do we do? And so the way Shopify has solved this is with an app store. So we internally build the core, and we make the rest possible by having a thriving partner ecosystem and an app store, which you can see here is a screenshot from. And so through APIs and integration points, partners are able to build everything else that isn't what most merchants need most of the time. And it's a huge business opportunity for them as well. We have merchants, or partners rather, making millions and millions of dollars selling apps on top of Shopify. So it's a great model. And with apps, merchants can satisfy their unique needs, partners can innovate, make money, and Shopify's core can remain simple. Okay, so this is a metaphor. So a metaphor we like to use internally to drive this point home is that of a computer operating system. So as most of you know, operating system, the kernel handles interactions with the hardware and exposes a set of syscall APIs that allow processes and apps in user space to do useful things on the computer. So I'm going to use this metaphor and apply that to Shopify. So in Shopify, we actually refer to our core Rails monolith as the commerce kernel. And this kernel exposes APIs to first and third-party apps, which you can see on the diagram. Those are just some logos from various apps. And then we have our commerce primitives, which are models like products, inventory, shipping, customers, those sorts of core commerce concepts. These are accessed via the kernel. So keep that in mind. I'm going to build on this metaphor a few slides later. I promise I will get to WebAssembly and AssemblyScript. I'm just setting the problem stage here. So here we might have an app, and it's interacting with Shopify in a few ways. So traditionally, these apps, they're hosted on their own infrastructure, provide their own UIs, and they'll use either GraphQL or REST APIs to talk to Shopify. Alternatively, Shopify might send a message to the app over some REST webhook when some commerce event fires, like say an order is placed and the app is registered to listen for that event. And these APIs and webhooks make Shopify extensible, and apps add value to merchants by exploiting that extensibility. So for many merchants, a few apps plus the core of Shopify is usually more than enough to run their business. But when you get to merchants at the plus level, their setup normally ends up looking something like this. And so on one hand, this is really good. It's the system working by design. Merchants can grow their business, and as they grow, they can add new apps to solve new problems. But on the other hand, there's a growing number of dependencies on these third-party apps can have costs. And so one of those is just an inconsistent product experience, with each app bringing distinct design patterns. There can be interaction effects between apps, and then there's scalability challenges. So a lot of these apps infrastructures just can't stand up to the load generated by large merchants that are doing flash selling. This is a very hard problem, and Shopify's spent a ton of money on this problem. A lot of these independent app vendors just can't do it. Furthermore, this type of architecture limits us to what I call coarse-grained customization. So having a really good REST API is useful, but what if a merchant wants to customize the deep internals of the system at a finer grain than what is exposed through, say, a REST API? So an example here that I'm going to build on throughout the talk is discounts. So Shopify provides out-of-the-box models for expressing some kind of a discount rule, and those models can be set up via an admin or via API. And so you can do things like buy one, get one, percentage off, and so on. But some merchants, especially the plus merchants, they have very complex promotions that could not possibly be expressed with these models. It would be crazy to try to build a UI to capture some of the promotions that these merchants run. And so, on the other hand, since most merchants don't need that type of complexity most of the time, it's our product principle to not overcomplicate our core to account for all of these possible promotions. So we need another way. We need to be more extensible. Okay, so metaphor step 2. I'm going to talk a little bit detour on this technology called eBPF. And so to be clear, our stack does not use this in any way, but it provides a pretty useful metaphor, so we use it. And so for those who don't know, the BPF comes from the Linux kernel, and it's a custom instruction set and a virtual machine for running those instructions securely inside the kernel. So a program is written in C and compiled to BPF bytecode, loaded into the kernel, and it runs in kernel space on some kernel event. And that program is actually provided by a user space application, but it's running in the kernel. So the initial use case for this was to allow user space processes to define their own logic for packet filtering. But since then, BPF has evolved to include many more program types across the Linux kernel. And so back to my simplified operating system diagram. Recall we have our user apps, our kernel, and our hardware. And so with BPF, we can have event hooks right inside the kernel that allow these user space programs, these user space BPF programs to run. And the instruction set actually is not even Turing complete. And so that's by design. Things like loops are disallowed. And that's so that each BPF program is guaranteed to finish quickly. And by having its own instruction set and VM, it ends up being secure. And so what does this allow for? This allows for safe customization of the deep internals of that kernel. So it's great for companies who need it because, programming the Linux kernel can be really challenging, really risky. You don't want to maintain a fork. And this is actually gaining in popularity more recently with infrastructure teams at companies like Facebook and Netflix, both using this. So for things like load balancing, DDoS mitigation, observability, it's a super useful technology, and it's growing. So I think this was really cool. I'm going to use that as a metaphor to talk about what we're doing at Shopify. And so back to Shopify and our problem of making it extensible. So we asked ourselves, how can this BPF type of architecture apply in our commerce kernel, our Rails app commerce kernel? What if these Shopify apps could run their own code securely and synchronously right inside of Shopify in a safe way? So could that help with performance and scalability of those apps? Could it help with the UX consistency problem I described? And could it ultimately allow partners to solve more complex problems for our merchants that they can't solve today? So if we could poke these extensibility holes in the monolith or the commerce kernel and allow for synchronous customization of Shopify's commerce processes, we thought that, we could definitely solve a lot of these problems. So this is a fake quote. But someone maybe said, let's build a development platform for synchronous extensibility of a commerce operating system. This was kind of the mission we set out to solve. But of course, if we want to take untrusted third-party app code and run it synchronously on our most critical systems, keep in mind these are real money transactions that are directly affecting the livelihood of more than 1 million merchants. So this is a very critical chunk of software. So that if we wanted to do this, it would need to be both fast and, of course, secure. And so we set out to look at technologies to solve this. We looked at V8, Google Functions, Amazon Lambda, other solutions to sort of serverless technologies to run untrusted code based on containers or VMs. Many of these suffered from cold starts or just slow execution performance. And a key requirement for us is because these customizations are running on commerce hot paths, so they are running right within the checkout process as somebody is buying something. Performance is absolutely critical. We can't wait for a cold start for a container to boot or anything like that. So I'm sure maybe you can see where this is going. We decided to see if we could build this platform with WebAssembly and AssemblyScript at its core. And so we started with some prototyping, and we actually found in our early prototypes that Wasm gave us the performance we needed, so it was super fast. It had compelling security properties, just didn't have cold starts at all, and it provided lots of interesting options for the dev experience, like potentially the ability to support multiple programming languages in the long term. And so I'm going to take the rest of this talk. I'm going to walk you through what we've done. I'm going to flip over to the live demo and sort of hopefully answer the question of how we can extend commerce with WebAssembly. So time to demo. This is in production, by the way, so it is very real. Terminal shows up. I'm assuming this is all good still. Cool. Okay, so here I have a terminal. Now I am acting as a Shopify app developer, so third party, not Shopify employee. I am building apps that I can sell on the App Store to add value to all the merchants on Shopify. So as a partner developer, I have access to this command line. It's called the Shopify App CLI. It's a fairly new piece of technology, but Shopify released this late last year to support app developers who are creating apps. And with this CLI, I'm able to create what we call a script project. And so our product is actually called scripts. And so you'll see that word thrown around in the various commands. And so I'm going to start by calling Shopify create script. I'm just going to call it Wasm SF. This is prompting me to describe or to pick the API I want to use. So we have a few APIs available. For this one, I'm going to use a discount. And that's back to our what I described earlier, which is that some of these discount rules are just super complex. And so we'll see how I can define my own discount rule with code. Cool. Okay, so I've got my project bootstrapped. I'm going to open that in Visual Studio Code. And let's look at what we got. Right on. Okay, so we have source and test directories. Pretty simple project structure to start. And everything we're doing here is AssemblyScript and WebAssembly. And we're also making use of Aspect as well for the testing stack. So what do I get? So if I open up my script.ts file, I get some function signature here. And this is really the kind of the most important part to take in. So this function accepts a checkout, and it returns a set of discounts. So as a developer now, all I have to do to implement some meaningful discount logic is I have to map this checkout object, which I can look into that API. It captures all the details of the checkout as the buyer is going through and adding products to their cart. And I can map that to a discounts return value. I'm just going to nuke out these comments here. We also provide out of the box a default, I would say just example script that does something that they rather than giving them an empty function, we give them some example code. So this example code, very basic. It iterates through the line items on the cart, and it applies a 10-cent discount to every line item. So this is what I get to start. I also get a test file. So this test file, again, provides some useful defaults. It tests the default function implementation that I got in my source directory. And so this is, again, based on Aspect. And we integrate that with the CLI. So as a partner, I can just do Shopify test. And so this wraps Aspect. And so out of the box right away, I have passing tests. And so let's go through making a tweak to this logic. So let's imagine I want to add a $100 discount to products that are on clearance. And I know that I've already gone ahead into my products admin and I've added a tag. So I can actually show you real quick what I mean by that. So here I'm flipping over to my store admin. So now I'm acting as a merchant. And so I have, 6 products in here: high heels, jacket, jeans, runners, and t-shirt. I believe the t-shirt has a tag called clearance. And I believe also I've set up, I think the high heels maybe have clearance. Yeah, they have clearance tag. So what I want to do is I want to write some logic that applies a heavy, deep discount to anything tagged with clearance. And just to kind of reiterate why that's important, I'm going to go over to this tab where I can see this is Shopify's admin out-of-the-box discount screen. And so this is where I can describe some of those simple discount cases I told you about. I can use a percentage discount, a fixed amount, a buy X, get Y. But one thing, for example, I can't actually apply a percentage discount by a tag here. So it lets me pick by collection or by product, but I can't actually do it by tag. So if I want to do that and I can't do it through this UI, how can I do that? And so that's where our platform comes in, where now I can allow a partner to write some code to express that discount. So I'm going to go back to my VS Code here and make that work. So, yep. Yeah, no problem. How's that? One more? Okay, cool. No problem. Okay, so I'm gonna just do a real quick change this script so that I'm not in here for half an hour. So I'm just gonna extract this line item variable and call it item. And I'm just gonna do that. I'm gonna say if the item variant product, and there's a tags collection. So if, and that I believe is an array of strings. So if that contains the clearance value, then I want to apply a discount. Is it not contains? What is the right? Is it includes? Yes, it is. You're right. There we go. And I'm going to do $100. This is cents right now. And I'm going to say Wasm SF clearance discount. Give that message. I save that. And of course, if I Shopify test, I expect my test to fail. We get some nice Aspect error messages here. And so no discounts were returned. I expected 2 discounts. So let's go edit that test. I'm going to flip back over here. This here is my fake. We have a bunch of builder and factory classes to support the developer to build their own cart and checkout objects. And so here in my test, I have, I think, a red delicious apple and I guess another Florida apple, maybe. I don't know. I guess that's maybe. I don't know what that is. Anyways, so I'm going to add a tag to this one here. And clearance And so then I would expect now only to see one discount that is I think $100 is that. I gotta go fix that. There we go. And I think I said, I'm just gonna copy paste that string into my test file. And so now if I Shopify test, oops, I should see. Cool, so tests are passing. I'm happy with this code. I want to actually run this. So any merchant that's running my app, I want to ship this code to them. I'll show you real quick that this here, this is back to Shopify now as a merchant. There is an apps tab. And so as a merchant, I can see the apps I'm already running. So I have this Mitch March 4th app, and this is the app to which I'm programming as a developer here. So let's run Shopify deploy. And so this first runs a slow query that needs a bit of tuning to get the list of organizations. So this is it already knows who I am, and so it's fetching a list of organization objects that I'm a member of, so that I can select the one I want to deploy to. And so you'll see what that looks like when it comes back. Okay, so I'm using this organization, and this is the list of apps. So which app do you want to associate the script to? So there's my March 4th app. I'm going to pick that one. And so then now this runs AssemblyScript, compiles the code, and does some other compiler hook stuff that we've done. And says I already have a script running on that extension point. So I forgot about that. So I got to force. This is just a check we have to make sure that the developer's not accidentally deploying something right over top of something else without knowing very clearly what they're doing. So let's force deploy that. And another step that I have to do, so now it says, cool, the script is deployed. We have another lifecycle step, which is just called enable. And that can be done through UI, that the merchant goes in and clicks a button. I can also do it through the CLI. So by default, the deploy doesn't actually activate any code. It just hosts the source, the WebAssembly on Shopify. So I need to enable that separately. And apologies, we've got to wait for this fetching organizations query again. This should be the last time. So pick my business, pick my app. And so there we go. So we can see that code is now turned on in this Mitch dev store. And that is the store that I've been showing here. And so now that code is running. What does that actually mean? So I'm going to flip over now and act as a buyer on that store. So this is my storefront. I have not done any branding or fancy UI for my storefront. So this is like the stock storefront you get with Shopify. But I got my catalog here. So I'm going to fill up a cart. So let's add a pair of running shoes to my cart. I want to add a pair of high heels to my cart. And let's add the t-shirt as well. Okay, so now we're going to go through the checkout so we can review the cart. And cool, so I move on checkout. And if the demo gods are happy, we can actually see right here. So immediately inline synchronously, I have the Wasm SF clearance discount. I don't know why that's, it's free because it's $60 and I did $100. So there we go. Whereas this high heels is regularly $250 and now $150. And because the runners weren't tagged with that clearance tag, of course the discount is not there. And so this is fully integrated. If I were to go through the checkout, I would receive that discount as a buyer. And that essentially concludes the end-to-end demo. I have a few more slides to go through, but this hopefully shows the way in which we can use AssemblyScript and WebAssembly to run custom logic to implement very complex business rules that we wouldn't want to code into our core monolith to avoid making it too complex. So we allow partners to inject their own code, and they can do it in a really secure, high-performance way with WebAssembly. So I think it's pretty cool. This discounts is just one use case of many we hope to build, but that's sort of it for the end-to-end demo. So maybe I'll zip through the rest of the slides, and if there's any questions on the demo or anything, we can get to that at the end. So cool. Okay, so just going to quickly go through sort of results and sort of challenges that we've seen so far with this. Okay, so it's fast. Latencies are measured in microseconds instead of millis. We've been super thrilled with the performance we're seeing on our stack. We're currently using Lucet as the WebAssembly runtime. I don't even know if I said that right. I don't know if it's Lucet or Lucet. But anyways, that's what we use. It's very fast. We have single workers able to do over 1,000 requests per second, and we're able to do hundreds of thousands of modules per worker. So the scale is just awesome. Tooling and language support. So this has been a challenge for us. And like I said before, or maybe I didn't say this, but the majority of Shopify's app developers they're used to programming in things like Ruby and JavaScript, on top of web frameworks. And so they're used to having these mature tools and large standard libraries and a lot of developer support systems. And with WebAssembly and AssemblyScript being fairly new, maybe folks know this, but there's not a lot of really great developer tooling built yet for AssemblyScript. So will we be able to give this audience AssemblyScript wrapped in our tooling, and can we sort of close the gaps to make that a pleasant experience, and still allow these developers to get things done? And so for AssemblyScript specifically, things like having closures, good IDE support, having better libraries, these are things that would really help our developers and help us as we push towards launching this worldwide. And in the meantime, it's really about, can our team bridge those gaps and make it as easy as possible, maybe not perfect, but good enough. And so the other big challenge we have is good debuggability and observability. So things like stack traces, logging, tracing, and so on. If a script or a chunk of code fails, we want to be able to give these developers really good tooling around so that they can fix it. We don't want to give them, low level, fault codes with no stack trace and just say, sorry, something's wrong. We want to give them something they're used to. And so this is a challenge for us. Not a lot of this comes easy out of the box, at least with the tools we're currently using. But it is exciting to be part of this kind of bleeding edge stack, and hopefully we can help really move the needle and make things better. So the last major challenge we're facing is in the API design. So this is specifically the APIs we're exposing to the app developers by way of the AssemblyScript classes. So if I look back at my code, right, this checkout object here, this discounts object, these have commerce APIs that we're exposing to these developers. And of course, I can click into this and explore what's available to me through that API. But this is a challenge because we're building all of this on top of a 15-year-old Rails monolith. And over time, the domain models of Shopify have evolved. Many are not perfect. There's a lot of technical debt like any large software system. And we don't want to expose any of that or leaky abstractions. We don't want to expose any of that to partners. And so we want to give them like a refined commerce API, but on the other hand, our team has to fit those call sites into, let's say, a fairly complex and very large code base. So that's a challenge. And that's especially complex in a world where we hope to expose many of these APIs available to partners. Okay, and so just to wrap up, just a few notes on what's next. So we're looking at WASI to see what we can do. So things like logging, observability, allowing these partners to write to standard out or to log some state associated with their script. There's some interesting use cases there. Things like permitting access to randomness or the system time so they can do different things. Today we just have pure functions, which creates some nice characteristics, but probably not sophisticated enough to solve all the use cases we're hoping to solve. And as we think about can we expose a data store or caching or some other APIs to these programmers, there are some really interesting use cases that open up. We want to continue maturing developer tools. And so as we move towards releasing this to the Shopify partner ecosystem, we want this to feel like a tier 1 development platform. We don't want this to feel like some cobbled together set of hacks that they can use to maybe make something work. We want this to feel like they were building for a real tier 1 platform. And that's so that we can attract and retain the best developers who want to make the best apps for our merchants and add the most value. And so these things like debuggers, testing tools, deployment pipelines, libraries, these are all important to make that experience really great. we need to add more APIs. So today, you probably caught the list. We just have a few of these APIs that you can use to program Shopify. In the future, we want to have tens or hundreds of these things so that the Shopify platform is deeply customizable with code in this way. And so that's just going to unlock a lot more value. And so if you put these things together, like the access to WASI interfaces, mature developer tooling, comprehensive commerce APIs, these third-party developers can move beyond these small functions I've showed you towards building like really full-featured AssemblyScript applications that run entirely on Shopify's infrastructure, and applications that'll guaranteed to be fast, secure, and scalable. And so that's going to unlock huge value for Shopify merchants all across the board. And I think this is all possible because of WebAssembly and AssemblyScript and the tools we're using, and Aspect, of course, in there as well, which is critical for our testing. So that is it. We're always hiring. Shameless plug. Connect with me. Happy to answer questions. Happy to go deeper on any of this stuff with the time we have left. So that is it for the talk.